Hello, today I'm going to do a one-dimensional kinematics problem, or a linear motion problem as sometimes it's called. So let's get started. A car traveling on the freeway has a maximum deceleration of 6.0 meters per second squared. What will be the car's stopping distance? Let me finish writing the problem. It starts out going 30 meters per second. Okay, so the first thing I always like to do when I have a problem like this is to draw a diagram. So let's start with that. So I have my car. This is at the start. At the finish, I'll draw it again. And I know that it starts out traveling 30 meters per second. And when it finishes, it is at rest, because it is asking us how far it takes it to stop. So the final velocity is just going to be 0. It's going to end at rest. All right, another thing that I like to do when I solve a problem like this is to choose a direction to be positive and choose a direction to be negative. So in this case, I'm going to say that forwards is our positive direction, backwards is our negative direction. That feels intuitive. All right. And now I can start writing down all the information for the problem. All right, what do I have? I know a bunch of things, but here's what I like to do. I like to write down all the pieces of information I could possibly have. So initial position, final position, time, initial velocity, final velocity, acceleration. The only one I don't have up here is average velocity. That can sometimes be helpful for problems, but typically with this kind of problem, you're not going to need it. So, unless the problem says otherwise, if you're trying to figure out a distance, it's usually pretty safe to set the initial position equal to 0. The final position in that case is exactly what we want, so I like to put a question mark next to the one that we want. We know it starts out going 30 meters per second. It's going to end going 0 meters per second. And the acceleration is going to be 6 meters per second squared, but I have to be a little bit careful. Since the car is slowing down, that acceleration is actually going to be negative 6 meters per second squared. Thing to be careful about, that's not always the case. Slowing down doesn't always mean negative acceleration. Negative acceleration could be speeding up if the object is moving in a negative direction, but in this case, the car is moving in a positive direction, so a negative acceleration will mean slowing down. Okay, now I need to choose what formula I am going to work with. The main formulas I usually work with are these ones. Final velocity equals initial velocity plus acceleration times time. Final position is equal to initial position plus initial velocity times time plus 1/2 acceleration times time squared. And final velocity squared is equal to initial velocity squared plus 2 times acceleration times final position minus initial position. I want to pick one of these formulas that has some of the variables that I am given, definitely has the variable that I want, but doesn't have the variable that I neither have nor want. So I do have that formula here. That would be this third formula, because it doesn't have time in it. All right, so I'm going to plug things into this formula. So I'll go 0 squared is equal to 30 squared plus 2 times negative 6 times x minus 0. So I get that 0 is equal to 900 minus 12x, basically. I'll add 12x to both sides, and I'll get 12x is equal to 900. And if I divide both sides by 12, I get that x is equal to 75 meters. I like to wrap up with a quick sanity check and just say, does that sound like a reasonable distance for a car to stop in? And whether or not you have a good idea in your head of how long 75 meters is, it's pretty long, but your car was going pretty fast on the freeway, so this is a pretty reasonable number for how fast or how much distance it would take the car to come to a stop. All right. If you have questions, feel free to leave them in the comments, and I hope this was helpful.